So what are the different types of machine learning uh, apps and algorithms that exist? Well, machine learning is broadly divided into three parts or three blocks. One is supervised learning, unsupervised learning, and reinforcement. So supervised learning is task driven. Okay, so you'll give a certain task to the algorithm, it will do something, and basis the response, basis the performance, you will judge whether it is good or it's performing well or not. Unsupervised learning is basically you'll give the machine learning algorithm uh, a lot of data. Okay, so it is very it's heavily dependent on data. Okay, so you will give a lot of data, and the machine learning system algorithm will automatically come up with a pattern or an answer or an outcome, and you will judge whether it is suitable for your use case or not. And finally, reinforcement, which is algorithms learn to react to an environment, so they are continuously exposed to an environment. When I say environment, it could be a temperature sensor based, or a self-driving car based, or could be anything else. And then reinforcements kick in. So what is supervised learning? Right, so you'll first train the model with lots of training data. That is, for example, just think of cats and dogs at the moment. So you're trying to train an algorithm to detect whether a photo has cats or dogs. So you'll first train the model with lots of training data. You will train by giving, let's say, for example, 1,000 pictures or 10,000 or maybe 100,000 photos of dogs and 100,000 photos of different cats. Okay, then you will train the model with the new data. After training all of this, then you will pick up a new photo and you will train the model with the new data and the logic derived in the previous step. So whatever machine learning algorithm derived from the previous training, you use that and the new data itself. Okay, and basis that you'll get a final output. Okay, so for example, so there's an algorithm and you are training with training data. So you're given input is 5 6 and output is 11, and the algorithm is to add, right? So which is basically 5 plus 6 is 11. Right, the logic is to add the inputs to give output. That is the logic that our algorithm has predicted. When you're predicting with new data, the input is 2 and 4. That is a new data that I give, and the logic was already determined from the previous training data. So the output should be 6, and that is what the algorithm is going to predict. Right, so there are two types of supervised learning. One is regression, which is to continuously predict the response for continuous data input. Okay, so you try to fit the response in regression. Okay, so in the previous example, for instance, the response value was the number 6. So in this model, you keep predicting what the response will be, which is dependent on the initial training data. So for example, the value of a stock, to determine the value of a stock in future is a prime example of using regression. Okay, or how many total runs can be on a board in a cricket game is also an example of regression. Okay, what is classification? Classification, you try to predict the response for discrete data input, that is binary answers. Basically, you basically want to classify the data into yes or no, hot dog or not hot dog, or cat or dog or something. So data can be grouped or classified in specific classes. Okay, and then you can classify the responses into different states. For example, will it rain? Is the mail spam? Is this cat or is it dog? Okay, then comes unsupervised learning. So in this type of learning, you don't provide any desired output or target. Okay, in the previous one, you gave a desired output that if I'm feeding you 5 and 6, the output is going to be 11, and the algorithm is made to understand this after by training them with a lot of data. In this scenario, obviously you can imagine that in supervised learning, you need a lot of data. So in the absence of a lot of data, you can only rely on unsupervised learning. So in this type of learning, the system is not given the desired output or target, and the algorithm is left alone to understand the patterns in the data itself. So a whole bunch of unstructured data is sent to the algorithm, and the algorithm is left alone to figure out the conclusion, the results. Okay, so for example, the some examples are if you're given a huge set of tweets, the algorithm is supposed to cluster based on the content of the tweets or emotions of the tweets or topics of the tweets, right? It'll create some sort of cluster. Similarly, you can give a set of photos, and the algorithm supposed to group them by the objects in the photo. So give me all the photos of beach, or all the photos of dogs, all the photos of nature, all the photos of cars, for example. Then comes reinforcement learning, and Udacity has done a fantastic job at explaining reinforcement learning basics. I'm sorry for that. Right. So in reinforcement, an agent learns how to behave in an environment by performing actions and seeing the results. So essentially, it behaves very much like a toddler. Okay. So a toddler sees that there is a fire. Okay, I need to avoid it. If there is a right, because it has observed it, right? So imagine your child, and you see a fireplace and approach it. You feel warm and realize it's a positive experience, but you try to touch the fire and you burn yourself, and now you realize it's a negative experience, right? So the agent was child, the environment was a living room with fireplace, right? In a similar way, the agents learn about their environment, or the programmed agents learn about their environment, and they react basis that, right? There are plenty of tools available nowadays for AI and ML app development. There are plenty of tools, and new ones are coming up on every single day basis. Some of the most popular ones are, like, for example, PyTorch, which is backed by Facebook. There's TensorFlow, which is backed by Google. And then there's Open, there's Apache Mohoth, there's Deep Learning 4J, there's AI One, there's AWS has a bunch of services which does a lot of cool stuff, right from audio processing to image processing to video processing to a whole bunch of stuff. So to conclude, machine learning has a bunch of very interesting applications and has different types of environments. There's supervised, there's unsupervised, and there's reinforcement. Reinforcement is one of the toughest ones, and there's a lot of work that is going on. Read about GANs, for example, GANs. uh, So machine learning is super cool. Supervised learning, unsupervised learning, and reinforcement. Supervised learning requires a lot of data, so that's why for a startup, for an early stage product, it might be very difficult to gather that kind of data to make any kind of sensible prediction. Uh, while unsupervised learning also requires a lot of data to make sense of the patterns, but at least you do not have to label, and you do not have to create a lot of training data set. Okay, and finally, reinforcement, in which you have to you have to create multiple agents, and you have to train each one of them. It's much more complicated, much more difficult to actually get any kind of sensible answer from it. But whenever you get it, actually the results are superb. Okay, that's it for now about machine learning. See you soon. Thank you.